Okay, so this video is all about vectors and scalars. So in physics, pretty much everything is either a vector or a scalar. There's not a whole lot of other things. If we're talking about numbers, quantities, physical values, then we're going to either be talking about vectors or we'll be talking about scalars. So, but I mean, seriously, what is a vector and what is a scalar? I mean, this is the first time you've probably seen these terms in these videos. So what are we talking about? Alright, that's what this video is all about. It's actually pretty straightforward, so this video should not be super long. Okay, so first, we have one of those two things is defined as follows. It is a numerical value or magnitude, a quantity that is fully defined. That means the whole thing, all you need to know in order to know what this quantity is its numerical value, which is also called magnitude. So magnitude is just a fancy word for the value of the number, okay? Or how big it is. So which one of the two, is this a vector or is this a scalar? That's the question of the moment, and the answer is this one is a scalar. All right, so scalar is that one. All right, which of course means, obviously, whatever this other definition is, it must be a vector. So here we go, a quantity that is fully defined only by both magnitude and direction, so you have to have both of them. That is a vector. A vector. So a quantity that is fully defined only by both magnitude and direction. So you can't just say the number. If you're talking about a vector, you have to have a direction. Now sometimes the direction is indicated just by plus or minus, like we were talking about with velocity. You may have guessed now, velocity is a vector. Let's talk about other things. Other things that are vectors. Alright, so here we have some other things that are vectors. Displacement. Displacement, which is essentially how far you, a change in position, but it's how far you are from where you started. Alright, so displacement. If I were to walk across the room and then come straight back to where I started exactly, then my displacement would be 0, because I'm back at the same place I started at the end. But the distance that I traveled is not 0, right? The distance is not 0. The distance, I covered actually some quantity of distance there. I went all the way maybe to the end of the room and back, possibly 20 meters worth of distance. But my displacement wound up being 0 because I went plus 10 meters to get to the other side of the room, minus 10 meters to come back. 10 plus 10, and then you add a minus 10, you get 0. So displacement is a vector. Distance is a scalar, right? Speed. All we're concerned with speed, if you recall, is the numerical value of the speed, not the direction. We don't care what direction you're going. Velocity, we care what direction you're going, so velocity is a vector. All right. Acceleration. Acceleration is defined as a change in velocity divided by the time it took for the change to occur. So acceleration is directly related to velocity, which means acceleration is also a vector. Now, what we'll talk about soon, we haven't talked about yet officially, is forces. And forces are all vectors. All right, other examples of scalar quantities are time and temperature, for example. All right, so that's pretty much it for this idea. All right, vectors, they involve direction. They involve direction and size. I've got a picture here just to reiterate that. Vectors are drawn. So if we talk about vectors, we usually draw them as an arrow. All right. So this is just a box that's sitting on an inclined surface, and then these are the forces that are acting on the box. You've got a force that acts outward from the box pressing on the surface, so that's called the normal force. You've got the force of friction, which pulls the box, tries to pull the box back up the slope as it slides down, and then you've got the force of weight, which tries to pull the box down. All right, this box might actually not be moving. It depends on how these three vectors all relate to each other. All right, anyway, we'll talk more about that later when we talk about forces, but this is just to show you vectors are drawn as arrows, and that indicates the direction. Cool, that's it. Awesome.